All right, we're going to continue our unit on radicals, and today we're going to talk about multiplying radicals. Before we do that, take a look at this picture. What belongs in the question mark? All right, how do we multiply radicals? First, you're going to multiply any coefficients, numbers in front of the radical. And then you can use the product rule, which says, let's take a look at this a little bit. You just multiply the two radicands. So we've really been taking something like this and working backwards and breaking it apart. So now today you're going to go back the other way for part of this at least. Okay? Once you have done that, all the multiplying, then you're going to simplify what you have left. In other words, break it apart again and put it into simplest radical form using the perfect radical and then the stuff that's left over. So we'll do a couple of these problems that's on this page. So you're going to take, the coefficients in front are 1, so there's nothing to do there. 27 times 5 then is 135. Okay, so that's what I just did, multiply 27 and 5. And again, when you are multiplying here, the indices have to be the same, but the radicands don't. Okay, like when you're adding and subtracting, the index and the radicand have to be the same to add them together. That's not the case with multiplication. So now, once I have this, now I'm going to break this apart. And I'm going to do the same thing that we did in our last unit. You're going to break it apart like this, right? A perfect square root and what's left over. So the biggest perfect square root that goes into a 135 is 9. And what's left over? 15, because 9 times 15 is 135. Again, perfect square roots first, and then this gives me 3 root 15, and that is my answer. Okay. Now there's a couple other problems. I put some extra ones on here. I just really want to go to this one in the lower left now with the cube roots, and then I'll show you on the next slide some of these other ones. Okay. So again, this one has coefficients this time. So when we're doing this one, we are going to multiply the 2 and the 5 first, okay, our coefficients. And now we're going to take, and notice they're both cube roots, so 9 times negative 24 gives us negative 216. Okay, you're going to use your perfect cube chart. And you probably will notice that on your perfect cube chart, 216 is a perfect cube. So this actually ends up being a nice number. It's negative 216, so that would give us negative 6. So this one actually, now we don't have any breaking apart to do. This would end up just being negative 60 as my answer. So kind of weird. So sometimes you'll end up, when you have perfect roots, you'll end up with just a regular integer. Okay, now these other two I did on the next slide, and I just want to talk about those. So here on the second one here, again, 3 root 10 times negative 2 root 18, and we're going to multiply the coefficients. So 3 times negative 2 gives us negative 6, and then the square root of 10 times the square root of 18 gives us the square root of 180. And then you break apart the square root of 180. And I did that, again, the biggest perfect square root that goes into 180 is 36. So square root of 36 times the square root of 5. Simplify that, and at the end there we get negative 36 root 5. Okay, and that last one in purple, multiply coefficients. So I have negative 3 times negative 1 there. That's really a negative 1. That's positive 3. And then they're both fourth roots, so 64 times 8 is 512. And then I would look for the biggest fourth roots that go into 512, and that would be 256, which goes in there twice, so 256 and 2. And then I would simplify. So the fourth root of 256 is 4. And then simplifying at the end, we get 12 times the fourth root of 2. So that's how you do those. And I want to go through a couple other ones with some variables in here. So we'll take a look at these as well, and then talk about binomials and how those work. So let's see. Here, same premise applies. Just remember when we multiply things with variables and exponents, we add the exponents. So this is 5, whoops, let's say 5 times. All right, so now I got 6 times 8 is 48. And then x to the 4th times x to the 5th is x to the 9th. Okay, and then we're going to take, and now we're going to break apart this radical. So if I do that, this is a square root, so I want, okay, what's multiples, since square root, multiples of 2 with the exponents, but I'm going to, biggest number that goes, perfect square root that goes into 48 is 16 and 3. 16 times 3 is 48. So now multiples of 2. So the biggest multiple of 2 I can get here is x to the 8th. I would have 1 left over. Okay, so this would simplify to 4x. X to the 8th, taking the square root, so this would be x to the 4th. Dividing, remember? The exponent by the index. And now multiply that, what's in front there, and I get 20x to the 4th times the square root of 3x. Okay, so really kind of the same thing that you saw before. Okay, so I'll go down here and we'll do this one. Notice there's no coefficients with this one. So here we go. I've got, put all this together first. So let's see, negative 3 times 36 is negative 108. A to the 7th times a to the 6th is a to the 13th. B to the 4th, b squared, is b to the 6th. Okay, and now I'm going to break this apart. Okay, now again, cube root of negative, you're always going to put that perfect, the negative with the perfect cube part. So this would be, let's see, biggest perfect cube that goes into 108 would be 27, and then 4 would be left over. Okay, now it's multiples of 3. So a to the 12th would be the biggest multiple, and then b6 is a multiple of 3, so that whole thing can go there. That means I have one a left over here and no b's over there. Okay. So now simplifying this a bit, that would give me the cube root of negative 27 is negative 3. Cube root of a to the 12th would be a to the 4th, and b squared. Okay, times 4, or that times the square root of 4a. And this should be, excuse me, the cube root. Okay, and that's kind of how you do those. I'll just take a look at this last one real quickly. Multiply the stuff in front. I think we'll just do this one and call it good. This is the 4th root. So now I'm just multiplying these. So p to the 5th and q to the 11th. Okay. And that would be p to the 4th and q to the 8th. And that would mean I'd have 1 p left over and 3 q's left over. So this would give us 14 times p to the 1st q squared. And then we just got this left over. Okay. And that's how you do those. If you do this other one that's in the upper right there, you'll end up with 3m to the 4th times the cube root of 10. I don't think we need to go through that one. All right, these are probably more important to go through. So I want to go through a couple of these. And hopefully these make sense. So this is binomials multiplying binomials. This process works the same. You're going to distribute just like you would any other time. So you're going to go like this, right? So when I distribute that first one, the coefficients I'm multiplying, I would have 5. And then the square root of 10 times the square root of 5 would be square root of 50. Okay? And then I'm going to do the second one. So I would have negative 2 root 20. Okay, and now I'm going to break apart. So this would be 25 and 2, and I guess 4 and 5. Okay, so now I have 5 times square root of 2 minus 2 times square root of 5. This would be 25 root 2 minus 4 root 5. Now this is subtraction. My indexes are both 2, but my radicands are not the same. So remember, adding and subtracting, they have to be exactly the same. So I would have to stop here. This is as far as I could go. Okay? All right. Let's go down here. Okay, so we're going to go this times this times this first. Okay? So 6 times the square root of 6 times 6 is 36. Okay? Now we're going to go here times here. So that would give us 6 times the square root of 12. Okay, now we're going to do these two and then these two. So that'd be minus 6 root 12 minus 6 root 4. Okay. All right, so what do we have? This is 6 times 6 plus 6 times, break that apart. Oh, don't need to do that. If we notice these actually in the middle, cancel out. Okay. So then, okay, so then we just have minus 6 times 2. So this is 36 minus 12, which should give us 24. How about that? Okay. I think we'll go through this one here too. These last two to just be sure. Okay. Again, distribute. 8 times 3, 24. 8 times root 10 would be negative 8 root 10. Now I'm going to do this times that, and then this times that. So this would be negative 3 root 10 times, or plus, excuse me, square root of 100. Okay, so we got 24. I can combine these middle ones, so that would be minus 11 root 10. And then plus, square root of 100 is 10. So I don't even have to break that apart. So now I'm just going to go, let's see, 24 plus 10 I can put together. That's 34 minus 11 root 10. And that's my answer. Okay. Okay, and then the last thing I want to go over is one with some variables in it. And that's it. All right. Let's see. We've got this times this first. So this would give us the square root of 36k squared. Okay, now we're going to do this. So this would be minus 2 times 3 times 15 gives us 45. K times k squared is k to the third. Okay. Now, 36k squared. Now, square root of 36 is already a perfect number, so we don't even have to break that apart. K squared is also a perfect square, so that's just k. And then minus 2. I can break this apart. 45 is obviously not a perfect square. So let's see, 9. And then we want multiples of 2, so k squared. 9 times 5 is 45. And then I'd have one more k left over. All right. And then simplifying this, finishing it up. That'd be 3k. So I have 6k minus 6k root 5k. Now, some people are said, oh, I can just go 6k minus 6k. No, you can't. The 6k is it's multiplied by that radical 5 square root of 5k. Now, if this other one had a square root of 5k, then you could do something, but we don't have that. So this would be my final answer. Whoops, sorry about that. This would be my final answer. Okay. All right. All kinds of different multiplying examples that you'll see. Hopefully that helps a bit. And in your planner, I want you to write multiplying radicals worksheet. That's your assignment today to work on. You have 8 problems and that are similar to different kinds like these. All right. Good luck.